I just thought I'd take a few minutes to show you a couple of hints on how to do problem 2 on this homework number 4 assignment. This is the one where you have to start off by assuming a flow direction. And so I got a couple of really nice questions during my office hours today, and I thought I'd show you some computational tools which could make this problem a little bit easier to solve. So the first thing is calculating the R values in this problem. You can use the spreadsheet to calculate the R values, and that'll speed things up a little bit. So here you can see, for example, in the first iteration, I'm calculating my R values just based on the fully turbulent flow assumption of F. And so here's some R values based on the fully turbulent flow assumption. And so using these, let's switch over and take a look at where things go in this problem. So the head situation, as I explained in class previously, and the hints that are given on the handout, we know that the head at C is going to be the head at A plus the losses through the pipe, whereas the head at C is also the head at B plus the losses through the pipe. So that's what this expression is saying. And so if we put in the actual numbers, we've got 20 meters of head at location B, 25 meters of head at location A, and then these are just based on those fully turbulent flow R values that I showed you on the previous page. Then the other thing we know about junction C is the continuity equation applies there, so that the sum of the two flow rates are equal to 0.2 cubic meters per second. So in bold is one equation, in bold is another, and what we're going to do is substitute this term of QBC in here and solve for QAC. So you can do that in your calculator. If you know how to set it up in your calculator, it'll be real easy. Or if you do it on Wolfram Alpha, it's also a way to solve the equation. Now keep in mind you can't use Wolfram Alpha on an exam, but you can certainly use it on a homework assignment. So let me just show you what it looks like if you do try and solve it on Wolfram Alpha, that equation. So I'm just going to try typing in this equation in here. So let's see if I can do that. 20 plus 454.1, 454.1. Now, instead of QBC, I'm going to put this in. Okay, so I'm going to say 0.2 minus Q, and what I mean by Q is QAC. And then all of that term is squared, is equal to 25 plus 10, 30.4 Q squared. And Q, remember, is QAC. So now all I have to do here, compute input, gives me a little graph of it. It gives me the two solutions here. So this positive solution is the one I'm interested in. So what that says is that QAC is 0.06076 cubic meters per second. So if I know that is QAC, I put it in this formula, I can find QBC. So now I've got my first guess of the flow rates. I can go back over to the spreadsheet, and in my second iteration, since I actually have flow rates, I can base my new F value calculations on the full version of the Jane equation, which takes into account the Reynolds number. So you have some updated R values, and so my first iteration R values that I just used were 454 and 1030. So the 454 and 1030. So now this updated one is 479 and 1115. So this just kind of shows how I still have this in Wolfram Alpha. I'm just changing the R value, 479.6. And this R value from 1030, it's now 1115.66. I solve again. I'm going to have a slightly different flow rate, 0.0614. So that's slightly different than the other one was. but I'm going to use this flow rate to calculate, this remember is QAC. I could use this to calculate an updated QBC, and then I can iterate again. I can calculate an updated F value. Now, the percent change compared to the previous F value is going to be smaller, but hopefully that gives you a sense for not only how the two equations are working together. You know, I substituted one into the other so that I've just got a single variable. And then this key point about how, you know, this can turn into page after page of hand calculations, and that's what my solution looks like. But if you wanted to automate things a little bit, you can toggle back and forth between spreadsheet, Wolfram Alpha, and then you do need to take some hand notes, just letting me know that you used, you know, some solver tool in order to find out what the flow rates are. So I hope that helps. See you in class tomorrow.